Hey everyone, let's discuss on how to solve the non-homogeneous second order differential equations by using undetermined coefficient when it's involved the trigonometric function as it at fx. Okay, so as we already know, to find the solution to our non-homogeneous second order ordinary differential equation, our y is equal to yc plus yp, where yc is the solution for homogeneous part here. Okay, so we will write the second order differential equation equal to 0 to be homogeneous. Then we solve this one and we will have our yc down here. Now we need to decide what is our yp. Okay, before this we use a different technique for case that involve the polynomial and also exponent, but for trigonometric, to decide on what is yp, you need another technique. Okay, the first thing is you need to list the family of derivative of your fx. So if you see here, you have fx is cos 2t, right? Okay, we will list of the function to the family of our derivative, which we will ignore the coefficient here. So the family of derivative of your fx here, okay, let list down like this. Okay, the family of derivative means what is the derivative of your fx. So derivative of cos 2t, you will get differentiate cos, you will get negative sign, right? But negative 1, we ignore the constant, so we just write sign. So differentiate cos, you will get sine 2t. Okay, then you differentiate sine 2t, you will get cos 2t. Okay, when you differentiate cos 2t, you will get back sine 2t. Okay, and when you differentiate sine 2t, you will get back cos 2t. Means this is the family of derivative for the trigonometric function where it circulate on the same derivative. Okay, let me give you example. If you have a fx equal to 4x to the power of 3. Okay, what is the family of derivative for fx? So you need to take the function x cube here. So differentiate x cube, you will get 3x square, right? But we ignore the constant in front here, so we take x squared. Okay, differentiate x square, you will get 2x. So we take the x. Differentiate x, you will get 1. Okay, and differentiate 1 is equal to 0. Differentiate 0 is equal to 0. So this one is the family of derivative. Okay, this one is the least family of derivative. Let's do another example. Let's say we differentiate, we have fx as 5x to the power of 4. Okay, so we want to list the family of derivative for this function. So you differentiate 5x to the power of 4, you will get 20x to the power of 3, right? We ignore the constant, so we write x to the power of 3 as the first family of derivative. Okay, you differentiate x to the power of 3, you will get 3x to the power of 2. So we ignore the constant here, so x2 is the next family of derivative. Sorry, x2 is your next family of derivative. We differentiate x2, we will get 2x, so x is your family of derivative. You differentiate x, you will get 1. You differentiate 1, you will get 0. So this is the list of family of derivative for your fx. So this is what we do for cos 2t here. We find the family of derivative of cos 2t, where we differentiate cos, we will get sine 2t, differentiate sine, we will get cos 2t, and it circulate on the same function. Okay, therefore this is the list of derivative. So after we have a list of derivative, we now can write our yp, where our yp is equal to any constant. Here we already use a and b, so we use c sine 2t, the first family derivative, plus with d cos 2t. Okay, so this is our assumption of yp. But before we can proceed, we need to check whether our yp and yc is linearly dependent or linearly independent. What do you mean by linearly dependent and linearly independent? The first thing is you need to write down the y1 and y2 from both yc and yp. Okay, if you see here in your yc, a y1, so your y1 is 1, b y2, so your y2 is exponent negative 4t. Okay, this is for yc. For yp, your y1 is sine 2t. Okay, this one cy1, so this one is your y1. Your y2 is cos 2t. Okay, and you compare both y1 and y2 in yp and yc, that the y1 and y2 for yp and y1 and y2 for yc is not related at all. Means that you cannot get here from here. Okay, you do any process, you cannot get here from here. Okay, so it's not related. So we said that it's linearly independent. When it's linearly independent, then you can proceed with your yp that we assume just now. Okay, so your yp now is equal to c sine 2t plus d cos 2t. Okay, let's do another example, because this video is focusing on how to decide our YP when it involves trigonometric function. Okay, let me give another example. Okay, let's see one more example on deciding what is YP for the case of undetermined coefficient, solving our non-homogeneous by using undetermined coefficient when it's involved fx trigonometric function. Okay, so as before, we need to solve yc first. So when I solve yc, at the end I will get yc is equal to a sine t plus b sine t. Okay, now we want to decide what is yp that we want to use in this problem. So to decide yp, the first thing you need to do is to list the family of derivative for your fx. So now the first fx is cos t. Okay, so we just ignore the constant. So you list the family of derivative cos t, differentiate cos, you will get negative sign, right? But we ignore the negative one, so we will have sine t. Differentiate sine t, you will get cos t. Differentiate cos t, you will get back sine t, and it's goes on with the same derivative. So we call this one as the family derivative of cos t. Okay, if you list down the family of derivative of sine t, you will get the same family of derivative as cos t, because differentiate sine t, you will get cos t. Differentiate cos t, you get sine t, and it's will repeat the same function. So we assume this is the family of derivative for our fx. So our yp now can be written as yp equal to another constant, let's say c sine t plus d cos t. Okay, like I mentioned to you before we can proceed with the one that we assume as yp here, we need to check whether this yp and yc is linearly dependent or linearly independent. So the easiest way how to check whether is both solution here is linearly dependent or linearly independent is by listing their y1 and y2. Okay, so as we know that this one is a times with y1 plus b times with y2. So the y1 and y2 for yc is sine t, and sorry, this one is cos t. This one is cos t. Okay, so the y1 and y2 for your yc is sine t and also cos t. Okay, same goes to your yp. So this one is c dot y1 plus d dot y2. So when you list down your y1 and y2, you will get sine t and also cos t. So if you can see your sine t, your y1 and y2 for yp and also y1 and y2 for yc is related to each other. So we call this solution as linearly dependent solution. So when we have linearly dependent solution, we cannot use the yp that we assumed before, but we need to write our yp equal to the one we write before, c sine t plus d cos t, but we need to times everything here with a variable t. Okay, so this is the new yp when we check that the yp and yc is actually linearly dependent. Then you can proceed to find what is your yp prime, what is your yp double prime, as we do before to find the value of c and d. So this is how to decide yp when it involves trigonometric function as fx, and we want to solve this by using undetermined coefficient. Thank you.